Hello, madam.
Good morning. Good morning.
Good morning, madam. Good morning, madam. Sorry, there was a small delay in my side. Now, can we
Sure.
whether the participants are ready?
Yeah. So, Dr. Sivarasu, we have some participants still joining. What I will do before we start is set ground rules similar to yesterday morning. The way some ground rules, I'll do that. And by the time I finish, we should be in a good position to start with the training.
No problem. No problem.
Okay. So, good morning, everyone. To start the third day of the training, I'll first begin with some ground rules. Similar to the first 2 days, I will request you all to keep your microphones and cameras off unless you have a question that needs to be asked to our trainer. The question answer round we can have at the end of the 2 sessions. So the forenoon session, right before we go for a lunch break, we can allocate about 10 to 15 minutes if there are any questions. If you have any questions during the session, please post them in the chat box and we'll pick them up in the last 10 to 15 minutes before we break. Similarly, for the afternoon session, in case of any questions, post them in the chat box, which we'll take up towards the end around at the end of the session. Also, there was an assessment form that was circulated yesterday for about 20 questions, and I believe a lot of you were able to answer it. Some of you missed out on it. So don't worry, we will be discussing the questions and the answers. So Dr. Sivarasu will be picking up that discussion again towards the end of the day today. And all the questions will be discussed. So those who missed out the questions will know what all questions were asked, and also the ones who attempted will know which were the right questions. Again, similar to yesterday, we'll have 2 feedback forms circulated, one in the forenoon session, right before we break for lunch, and we'll close it within half an hour of circulating that. Similarly, for the afternoon session, we'll circulate another feedback form, and again, we'll give a time of half an hour for you to fill up the feedback form and then close the responses. In case there's an assessment questionnaire, we are still in the phase of designing it. If there's an assessment questionnaire, I'll be making an announcement in the afternoon session for the same. And the ground rules remain the same. So this time, for an assessment question, please, let's make sure that we follow the time that has been set. You might be facing some internet issues for which we can allocate about 5 to 7 minutes extra, but we can't keep it open for longer than the stipulated time. So please bear in mind that we'll follow the time very strictly on the assessment questionnaire if we're circulating one towards the end. So that's all from my side. If there are any questions from the participants on the instructions, I can take them up in the next 1-2 minutes. If there are none, then we can start the training formally. All right, I think there are no questions forthcoming. So Dr. Sivarasu, with this, I'll just hand it over to you and you can formally start the training for today.
Thank you, madam. Good morning to all present here. Again, welcome back to the last and third day of this TOT program. Today, we are going to discuss about the thermal system, especially boiler, steams, furnace. Then finally, we are going to touch up with the heating, ventilation, air conditioning system. Because our session is mainly focusing on the energy efficiency, both electrical system as well as mechanical systems comes into picture. Whenever if you go to industry, sometimes electrical is going to be very higher than compared to the thermal system. Sometimes thermal is going to be higher than compared to the electrical system. But sometimes it is going to be same. But some industries may have only thermal. Mostly thermal. Some industries may have mostly electrical system. Thermal means they are using LPG, diesel, petrol, wood, furnace oil, then other kerosene, suppose natural gas. Those are all comes under the categorized fuel for the thermal energy. One important point in this fuel is these fuels are represented either in terms of kg or in terms of liter or sometimes in terms of the natural cubic meter. So therefore, the calorific value of each and every fuel is going to be different. So calculation part, and their operating efficiency, everything is going to be slightly changed whenever if you change the fuel type. Of course, our ultimate aim is going to be the same. We need to heat the water, or we need to heat the air supplied to the process. And similarly, we need to cool the air. So only thing is these two. Either we have to cool or heat. These two will be happen. These two will be to be happen for the medium, whether it is going to be air or fuel or steam or water, whatever it may be. Okay. Now, again, before going to talk about the technical discussions, I just want to show you the yesterday missed point is National Building Code. I told you in the lighting system, we have a National Building Code to be followed for measuring the illumination level of one particular room based on the activity taken place in the room. And of course, we have one more standard that's called SIWI standard also available, but most probably we are using the NBC standard, because NBC standard not only speaks about the illumination level, that also speaks about all the aspects, including the civil, mechanical, plumbing, electrical, and almost all the parameters, which is available in the net itself. If you have a copy, you can call me up or mail me separately. I will send you. National Building Code, we have on part 1, part 2, two separate things are available. Standards are available. Now, I think it is visible. Am I correct? Madam, is it visible?
Yes.
Okay. Now, this is the recommended values of illumination as per the National Building Code. IS 3642 is the standard. Part 1, 1992 was released, and it was amended in 2016. Each and every activity is represented here. In that, we have a separate activity. For example, agriculture and horticulture. In that, you have a farm, workshop, a milk process, and particularly in that, what are the other additional activity taking place? And this is the range of illumination level, minimum, average, and maximum levels. And they are also giving the glare index. So that is a neglected area of the lighting system, glare, which is not directly coming to the space, but that is coming to our eye. So because of that one, we are classifying the glare index into 3 different categories, 1, 2, and 3. And how much is the glare applicable for a particular area? So I think moreover, we have 12 different activity, 12 different categories are available in the activity. For example, coal mining system, electrical system, and similarly for metal manufacturing process. Then you can have some foundry applications. Then you can have ceramic industries. In that, we have separate areas like furnace room, bending room, annealing room, mixing area, beverages area, silvering area, chemical factories, and what are the level of fluxes to be maintained, mechanical engineering like steel structure. Then we have electrical and electronics engineering like a panel board room, PCB manufacturing process like that. Then food and beverages industries, textile industries separately, how much amount of light should be maintained for each and every rooms, every area. Leather industries, clothing and footwear industries. Then we have timber and furniture industries. Almost, I think, 19 categories are available. Paper and printing industries. Then we have plastic and rubber manufacturing industries. Distribution storage type of things like a warehouse, like that. Then we have commercial buildings, commerce offices. Then we have service industries. So that is also represented. Then retailing shops, shopping malls, and places where we have a public assembly like booking office, auditorium, dressing rooms, churches, mosque, temple, cinema theaters, common halls like that. Okay. So it is also available. NBA separate standard is also available for education industries, transport. Oh, it is 23 general building area. It is up to 23 general building area. You can see there is a boiler house. Boiler house should be having this much amount of lighting illumination level. This is for general boiler. So boiler control room, boiler front area, and other things are represented here. Even compressor room will also have their own standard of lighting system. Okay. So that is the point I want to show you before going to talk about that. Then we have a quick recap about the previous class. Yesterday we discussed about the basics of energy management system. We start with the type of energy. We have 6 different classifications. Then each classification we have the separate divisions are there, and we discuss about the terminology, definition for each and every type of energy. Then we discuss with the different type of calorific values. We start with the basics of electrical energy, basics of mechanical energy or thermal energy. What is the unit represented for electrical energy? What are the parameters for electrical energy? What are the parameters for thermal energy? So what is the respective unit? How to convert from the thermal quantity to electrical quantity, and vice versa. Then we discuss about the power system application, power system, especially the LT consumer, HT consumer, especially for the Tamilnadu region. Then who are LT, who are HT, what are the minimum criteria to be maintained for HT and LT consumers. Then we discuss one electricity bill for LT consumer and as well as HT consumers. We discuss so many parameters like permitted demand, sanctioned demand, recorded demand, power factor, kilowatt hour consumed, e-tax, meter rent, adjustment of the electrical energy we drawn from the supply, wind adjustment. So many things we discussed in the morning session. Again, in the afternoon also we discussed the same thing, but we elaborated the discussion with the help of a lighting system. Then how you are going to take the lighting system and what is meant by an energy auditing, what are the tools are applicable for the energy auditing system, and each tool will be applicable for measuring which type of parameters and what are the things to be measured, what are the things to be calculated. Then followed by what is the energy management commitment given by the management, what is energy management policy, energy auditing policy, and why we have to do energy auditing, what is the need for conducting the energy auditing, what are the types of energy auditing, and which application we are using a detailed energy auditing or preliminary energy auditing or targeted energy auditing or measurement and verification and energy auditing. Then we discuss about the electrical motor. 99% of the 90% of the motor are squirrel cage induction motor, and how we are going to use the induction motor for our application in the industry, and what are the energy efficiency perspective and energy saving possibilities are there in the electrical motor by replacing the old motor with a new IE3 motor or operating the motor. If the load is variable, we can use the variable frequency drive. Undersizing the motor, oversizing the motor is not recommended. You can undersize the motor. When the load is going to be lesser than 40%, you can use star delta again starter to reduce your fixed loss of the system. Then we discuss about the pump compressor. Of course, it is going to be what you call it is an extension of the motor. Application of the motor is going to be compressor, blower, and fans. Okay, now I have 2-3 questions are available with me. So I am going to ask now the participant. I request you to answer the question with your chat box. Kindly get ready. We can spend at least 5 minutes time to answer your question. Answer these questions, and then we will move on to today's topic. Are you ready? Can I ask the question? Anybody can answer. There is no rule. Anybody can answer. You can just type the answer in the Google chat box. Okay. First question. Question number 1. Electricity is a commercial energy or non-commercial energy? Whether the electricity is a commercial energy or non-commercial energy. Now I open the chat box. I'm waiting for the result. Please use your chat box and tell me the answer. Don't open your mic. Almost 20 seconds passed, but no answer. Commercial energy. Okay. Commercial. Yes. Commercial energy, because it is sold in the market. It is sold in the market. Exactly. Kirtana madam, Sumati madam, correct. Yes. Muthuvinayam sir, correct. It's a commercial energy. Very good. I appreciate your enthusiastic. Aravindan sir, very good. Sindhil Rani madam, very good. It's a commercial energy. Now the second question. What should be the minimum power factor to be maintained for LT consumer in Tamilnadu? I repeat, what should be the minimum power factor to be maintained for LT consumer in Tamilnadu? Okay, good. So, sir, it is not. It's wrong, sir. You are mentioning for HT consumer. I'm talking about the LT consumer. So, for LT consumer, Sumati madam, it is correct. 0.85. Kirtana madam, it is correct. Kirtika madam, it is 0.8 is not correct. It is 0.85. Mashankar, yes, sir, it's correct. 0.85 is the minimum value to be maintained. Very good. Revati Madam is correct. 0.85 is the correct value to be maintained without any penalty. So minimum benchmarking level. For HT consumer, it is 0.9. I appreciate. Very good. I appreciate. Very good. So what is the meaning of international efficiency? IE1, IE2, IE3, IE4 motor. We discussed yesterday. Now in India, which type of motor is currently practiced? IE1, IE2, IE3, or IE4? We are using energy efficiency motor for our normal application. In India, which type of motor is currently practiced by industries? Whether IE1 motor or IE2 motor, IE3 motor, IE4 motor. E2. Okay. Only one answer. Kirtika Madam, IE2. Umashankar sir, IE2. Ashok sir, IE2. Okay. It is almost correct. IE2 motor is the currently practiced, but IE3 was to be practiced. The government, it is not GO. It is voluntary, not mandatory. It is voluntarily you have to go for an IE3 motors. IE3 motors, but keep remember that as of now, IE2 motor is mostly followed. Very good, correct. Now the fourth question. You have two type of compressor. One is a reciprocating compressor, another one is a screw compressor. Okay. Now my question is on the screw compressor. If the leakage test of the compressor, I'm conducting a leakage test of the compressor, and the compressor leakage percentage is 40%. Is it a good or bad? My leakage percentage of a compressor is 40%. Is it good or bad? It is bad. Then what is the minimum value you have to maintain? It is bad. Yes, correct. What is the minimum value you have to maintain? There is no exact rule is available, but what is the minimum value it should be have? 10 to 15% is slightly higher, madam. 5 to 10% is the correct value. Kirtika, madam, you are absolutely correct. 10 to 15% is it is a very higher value. Prem Kumar sir, less than 10% is correct. You can maintain between 5 to 10% is almost correct. You can maintain it's a good good value. I appreciate, correct. Okay. Now, what is ISRI? I told you ISRI standard is available. What is the expansion of ISRI? Anybody? ISHRAE, ISRI. This is the last question. No one have the answer. Indian Society of Heating, Refrigeration and Air Conditioning Engineers. Exactly correct, sir. So they are follower of ASHRAE, American Society of Heating, Refrigeration and Air Conditioning System. They have their own codes and standard for the HVAC system as well as for the indoor air quality. Not only for the indoor air quality, they have an indoor environmental quality. Environmental quality means they have 4 different verticals are available in the IEQ, indoor environmental quality. Number 1, indoor air quality. Number 2, lighting. Number 3, thermal comfort. Number 4, acoustic sound. So these 4 to be taken into account for EQ. Okay, thank you. I think you are having a very good enthusiasm to answer the questions. Now we move on to our main topic. Today we are going to discuss about the mechanical thermal system. So we start with a boiler. It is very simple to understand the concept of thermal system. I told you we have only one formula is going to be applicable for thermal system. That is M into Cp into delta T, where M is the mass, Cp is the specific heat of the system or the medium what you are going to heat up. Then delta T is the change in temperature. So from which temperature to which temperature you are going to change the change the medium. Okay. So this is the boiler. I think it's visible, correct? Visible now? Yes, okay, thank you.
Visible, sir. Visible.
Okay, thank you, sir. Now, boiler is a very important parameter, very important equipment for most of the industries, especially for the rice industries, rice manufacturing industries. Similarly, for food processing industries, textile industries, leather industries. Then sometimes we may have a refineries. Also, we are using the boilers in a huge capacity. Okay. Now, the ultimate aim of the boiler is to produce the steam. The produced steam can be used for process application. Either the process may be directly or indirectly. You can use the steam directly to the system or indirectly to the system. Ultimate aim is to pass the heat available in the steam to the process. So that can be either directly or indirectly. So indirect passing or direct passing, that's different. Okay. Now, how to produce the steam? We need a water. So first of all, we need a water, and that water can be boiled more than 100 degrees. Am I correct? So when you boil the water, when you boil the water more than 100 degrees, automatically it will become steam. So yesterday we saw the changing of the phases from one to another by giving the calorific value, by giving the energy. Automatically the temperature will be increased. So the normal temperature or ambient temperature is between 0 to 100 degrees for the water. Okay, but it should be available in the atmospheric temperature or the room temperature. Normally it is in the room temperature, maybe around 25 degrees, 30 degrees, 32 degrees. Okay. Now you are giving a heat by giving by either by LPG or by wood or by coal or whatever may be. And because of getting the heat, then the temperature of the water get increased. So when it reaches 100 degrees, automatically the vapor comes out. That means it changes the phase. Liquid will be changes to gaseous states. Okay. Now that can be again used. That can be properly taken through a piping system at a required pressure and a required flow, and that can be used for process. This is the very simplest definition or explanation for the boiler. Okay. Now you can do this. Normally we are doing this for our regular activity, boiling the water for our cooking application, bathing application in our home. But this is for industrial application. That's all. Only thing is industrial application. So therefore, we need a closer vessel or closer chamber. So in which you need a proper firing system, proper fuel can be fed to fire, and you need a proper amount of air or oxygen. Exactly speaking, it's going to be not the air to burn the fuel. And you need a proper system of flowing the water, and that will be properly heated, and that produces a steam. Now the produced steam can be very properly, very safely taken out from the boiler, and that will be properly routed to the process through a piping system, right? So this is one case one or stage one. Okay. Now let us assume that I produce the steam and I transfer the steam from boiler to the process through a piping system. Okay. Now the process is using my steam. So after using my steam, this is the process completed. Then what about the steam? So what happened to the steam after usage? So what will happen when the steam use it completely? Then automatically it starts condensate. Am I correct? Because the amount of energy you taken, the steam energy, the amount of energy available in the steam you are taken for the process application. So when you take the energy, what will happen? Again back, you are giving the energy. Automatically it start from water to gas. Correct? So if you take the energy, then automatically it again came back to the original shape. That means from gas to water. Again it's back. So you're taking the energy for your process application. So again it will back to the water. That means it's called condensate. Okay, so it starts condensate. Now that condensate will be normally again back to the usage, again back to the boiler application. We will discuss why the condensate to be taken and why how it is more important for taking the condensate. So this is the second cycle. So first cycle, you have water can be boiled up and produce the steam, and that steam can be transmitted to the process. So after the process, the condensate water again back to the boiler feed water tank. Okay, so this is the second cycle. So the entire loop has so many energy conservation process, so many energy saving process also available. Saving possibilities are also available. We will see one by one. Okay. So first of all, we will discuss about what is meant by a boiler and how it is going to be important and how it takes the fuel and all those things we will discuss. Then we will go by one by one. Okay. So it is a pressure vessel which will produce the steam, and water is converted into a steam with the help of a heating of the fuel. Right. So the fuel may be a coal or LDO, light diesel oil or furnace oil, natural gas, LPG, high-speed diesel also, rice husk. So the second category is going to be rice husk, coconut shell, bagasse, wood chips, agro waste like any other agro waste. Even rice husk is also agro waste. So when you go to any rice industry, rice manufacturing industries, especially modern rice mills, they will use the rice husk as a main fuel for running the boiler. Okay. Now 90%, not 90, it's going to be almost 100% of the rice husk is going to be completely used for the by the same industry as an input for the boiler. Okay, so they no need to buy an additional equipment or additional fuel or alternate fuel for burning the boiler. Now the boiler can be very importantly, the specification of the boiler should be very important. One is what is the capacity of the steam generation that can be represented by TPH. That's called tonnage per hour. So how much amount of steam it can be produced per hour. Either it may be 0.5 or 1 or 2 or 3 or 4 or even 6 or different category. Okay. So how much amount of tonnage it can produce per hour or in terms of kg. Either if it's a smaller value, we are representing in terms of kg. When it is a very higher value, then automatically it can be represented in terms of the tonnage. As most of the people from the college faculty background, education institution, 99% of the education institutions are having boiler for producing the steam for cooking application. I don't know whether you people go to the canteen or mess area or kitchen area to see what type of boiler they are having. Recently, I went to one college in Erode where they are using 0.5 tonnage of boiler to produce the steam for cooking application. So normally for hostel, they are using the steam for cooking the rice, boiling the vegetables, boiling the water, boiling the milk normally. So most of the time it will be a 0.5 kg of boiler. Sometimes it may be 1 ton boiler. If the capacity of the mess or if the capacity of the hostel is going to be higher, the number of students are higher, then you may require a maximum of 1 pph boiler. This is the maximum. Class one minute. Okay, sorry. Is it here? Able to hear my voice, sir?
Yes.
Yes,
okay,
sir.
Yes, sir. Thank you. Then same thing similar to the compressor. The capacity is TPH, but also the working pressure. At what pressure you are developing the steam? Because you are supposed to travel you are supposed to send the steam to the process. but the process may be some distance away from your boiler. Normally, the boiler is one area, one place, and the process is in other place. So you need to transmit the steam with the help of a piping system, and you require a force. So this is again similar to the voltage in the electrical system. So you need to produce the steam at required pressure. Then only the steam will flow from your boiler to the end of the process. Sometimes it may be 1 kilometer or even 2 kilometers from your boiler. If you go to the leather industries or even modern rice mills, somewhat the boiler is going to be very far away from the dryer area. It may be around 0.5 kilometers from the boiler area. So you need a proper pressure to flow the steam from your boiler. Okay. Now the diagram what here shown is the simple example, a simple representation of a boiler. It's a pressure vessel where you have a water is flowing into the tube. Sometimes water is flowing into the tube. Sometimes fire is also flowing to the tube. That's basically depends on what type of boiler is. So it is a water tube boiler. So in the tube, when the water is flowing, this is called water tube boiler. So now the water is flowing inside the tube. The fire is in the outside. So this is called water tube boiler. So we have one more type of boiler that's called as a fire tube boiler. So in that boiler, the water is available in the outside, whereas fire will be flowing inside the tube. So either way, you need a heat transferring between your medium. So you need a heat transfer for your water. So that's called as a fire tube boilers. So basically, fire tube boilers and water tube boilers depends on the application where you are using. But most of the time, water tube boilers are normally used. So it's a closed chamber where you can have this type of arrangement. You need to feed the water with the help of a tank separately, which is not shown here. This is that means that is available in the upcoming slides. Then you need to feed the fuel here, and you have to burn it. So because of the burning, automatically the fire, the temperature increases, and that temperature is passed on to your boiler, water, and the water gets heated up. So when the water gets heated up, then it will develop a steam, and steam will go in the up. So that will be again at required pressure, because it's a completely closed one. So therefore the pressure is built up. So when the required pressure reaches, then automatically it went to the open valve and the steam start flowing. Okay, this is the water inlet type inlet, whereas the steam outlet will be here. Okay. Second important point is whenever you burn the fuel, then automatically the flue gas will come out. The fumes will come out. That should be properly evacuated. Otherwise, this is available inside the chamber. Sometimes the pressure will be higher, so that may have a very bigger impact on accidents. So therefore, you need to. Hello. Sometimes you need to evacuate the flue gas at a very convenient method. You duct out the flue gas because it contains most of the time it contains the ash. This is the number 2. Number 3, you need a proper fuel and combustion chamber and combustion system to produce the necessary heat. So that is another important point that will be taken into account. We will discuss those points later. No problem. So this is the normal nomenclature or the detailed specification of a boiler. So let's assume that I have 2 different boiler. One is the name of the boiler is here. One is a Thermax boiler, other is a Beeson boiler. Pressure of the boiler is 10.5 kg maximum pressure, kg per centimeter square at bar. The temperature is 180 degree. 180 degree is the steam temperature. Okay. Now the flow is tonnage is going to be 5.8 tons, and maximum and minimum is going to be 2.5 tons. So you have to operate between 2.5 ton to 5.8 ton. Okay. So below that, if your requirement is below, if you are operating, then the boiler efficiency will come down. And similarly, you should not go above that one. That means boiler will be overrated. Something similar to you are operating the motor at a very higher load condition, more than 100%. So it is not advisable. Normally, it is not advisable for a longer time, but for shorter time, it is advisable. But for a longer time, it is not advisable. Okay. And similarly, the actual steam generation, this is an average value. It's going to be 4.8. Then what is the fuel used is firewood. Most of the cases, firewood is going to be the normally used fuel for application. Then what is the average daily fuel consumption? Daily fuel consumption, 41 tonnage. For one system, another one is an 38 tonnage or 38,000 kg is the firewood consumed. Then what is the flue gas which is coming out of the? I told you, whenever if you burn the fuel, automatically the fuels will come out. That should have that is called as a flue gas, and that flue gas temperature is 168. And another boiler we have an 190. But the nominal flue gas temperature is 180. So if you cross more than 180, then there is a problem. If it is lesser than 180, then there is also a problem. Okay. So it may be around 160 to 180 is the correct value. Sometimes it may go even 200. So 200 is slightly okay, but not correct. Okay. Now feed water temperature is 80 degree and 55 degree. I will tell you what is the feed water temperature. The makeup water in terms of kiloliter per day is 66 kiloliter or 66,000 liters for both the cases. Okay, these are all the basic parameters by represented in the boiler. Of course, it is all the parameters are not represented in the boiler. All the parameters are not directly connected to the boiler. Some parameters are directly connected, like for tonnage, average steam production, pressure, the name of the company. So these are all directly connected to the boiler, but these are connected to the auxiliary of the systems. Okay. Now you can see the boiler, the structure, how it can be produced. The steam is. I already told you that we have a fire tube boiler or a water tube boiler. That basically you have a single pass or two pass or even three pass. Normally 3-pass boilers are used. I mean, 3 different ways are available to flow your water or the fuel, sorry, or the fire. If it is a fire tube boiler, means in 3 tubes the fire will be going, or if it's a water tube boiler, means in three tubes the water will be flowing. So basically, it's based on the passes, the capacity will be increased. And first pass, second pass, third pass, it is going to be an alternate one. It is not in the same direction. It is in the alternate one, and finally it will go produce the steam. The steam will go out, and the chimney will go out. In the chimney, the flue gas will go out. Sometimes the packaged boiler completely closed. Everything is going to be completely closed. This is called packaged boiler. It's very faster operation, and the efficiency is going to be around 82%. But normally, the single pass boiler, the efficiency is going to be 55, and 3-pass boiler is going to be 82. So mostly in industry, we are using 3-pass boilers, of course, having an efficiency of 82-85%. Okay. So apart from that, we are having other boilers are available. That's called as a traveling stalker boiler, which has an efficiency of 65-75%. Then we have a fluidized bed combustion boilers, BC boilers, which has an efficiency of 82-86%, which is normally higher. Pulverized fuel boilers. Now this is a very good things which having a higher efficiency of more than 85%. Okay. Now this is the fire tube boiler, where your fire will be passing through the tubes. Whereas the outer side the water will be available and gas will be go out and steam will be go out, and like this. And this is the cross section or a cut view of a fire tube boiler, where we are injecting the fire in the tubes, whereas they're surrounded by the water. Okay, this is the fluidized bed combustion, where you can have water will be available. You have a blank in which you are having a fluidized bed in which you are placing your fuel. So this is already we saw that the calorific value of each and every fuel. Now we come to the point of the major area, major systems what we are using for the boilers, right? Now we will take one by one. One by one, we will elaborately discuss. Then we come to the point of energy efficiency points. Okay. Now I need to produce a steam. So therefore, I buy the boiler. Okay. So I buy the boiler. I install it. So either I can use a fire tube boiler or water tube boiler. Now this is the example of a water tube boiler where the water is going. Feed water will be coming here, and which is going in the tubes. So here we are having a fire, and fire will produce the necessary heat, and that heat can be trapped by can be transferred to the water. And because of getting the heat, the water will become a steam, and the steam will be going to the process. Okay. Now one by one we will discuss. Right. Now for need to burn the fuel, we need. What are the things we need? Okay. First of all, we need a very proper fuel, and that should be in the closed chamber. Am I correct? You need to produce, or you need to put the fuel in the chamber, and you need to set a proper firing system. Correct? So for proper firing system, what is the main important essential thing? That is air. No, it is not air, it is oxygen. We need oxygen. Okay, so where I am getting the oxygen? Where I have to get the oxygen? Oxygen is available in the air. Am I correct? How much amount of percentage of oxygen is available in 1 kg of air? Anybody? Can anybody tell me in the chat box? What is the percentage of oxygen available in 1 kg of air? 1 kg of atmospheric air. Anybody? No. I think most of the people are not having the answer, or they put the system on and they went up. Hello. Okay, I will tell you. I don't know. Maybe 21%. Dr. Srinivasan sir, almost correct. Almost correct. 21%. Correct. So in the 1 kg of air, yeah, 20 is going to be close, Ashok sir. It's correct. 21% is going to be almost correct. 21.8%. Approximately 22% for 1 kg of air. So we are getting the atmospheric air. So that is having oxygen. So how to get the atmospheric air? We need a separate motor. Am I correct? We need a separate blower, not a motor. So we need a blower. That's called as a forced draft blower, FD blower. Okay, so we need an FD, forced draft FD blower, FD fan or the blower. So that will take the air from the atmosphere, and that air has an oxygen. That oxygen is supplied to the system, and because of the oxygen, the fuel start burning. This is very important point, number one. Okay. Now, the second important point, to need a 100% combustion. If you want a 100% combustion, proper combustion, then we have so many advantages. I will tell you, if your fuel is 100% combusted, 100% combustion takes place, then the main advantage is 100% heat is transferred to your water. Number one. Number two, ashes will be lesser. Amount of ashes produced will be so lesser. Number two. Number three, you are very quickly your water will convert it into ST. So these are all the direct advantage. Okay. To assist 100% combustion, there are three important T's are available. Three T's are important. Number one, temperature. So we require a very good temperature. We require a very good temperature to be maintained inside the chamber. Number two, turbulence. Turbulence means a very good turbulence in the chamber. That means a huge amount of, very proper turbulence of your air to be mixed with your fuel. And third is the time. So you need a sufficient time to be maintained inside the chamber. So three T's are very essential, very important for 100% or complete combustion. One is a temperature, second one is a turbulence, and third one is going to be a time. So when these three are very pakka, then 100% combustion will take place. Then that will give an added advantage. Okay. Now coming to our main discussion, we have a forced draft fan, which is an electrical quantity. Now you can see we are talking about the thermal boiler, but we have an electrical parameters also available. So we need a blower, and blower can be used for pumping the air, pumping the oxygen in the air to the system. Okay. Madam, ஒரு presentation இருக்குங்க மேடம். சார் நான் ஒரு presentation இருக்குங்க. சொல்லுங்க சார், என்ன ஒர்க்குங்க சார்? சொல்லுங்க. Sorry. Then we have the transferring of the heat. Then heat can be transferred to the water and steam can produce. Right. What happened to the air? So now air is assisting for you to give the enormous amount of energy from the fuel. That energy can be transferred. Because of that energy, the water is heated up turn into steam. Then what happened to the air? Then the heated air will go out to the chimney as a flue gas. Okay. Now, if you pass more amount of air than required, then what will happen? This is very, very important. So that is why we require to operate the FD fan at very correct speed. So if you are pumping more amount of air, more amount of oxygen will be pumped into the system. You are thinking that you are thinking that more amount of oxygen you are supplying, so therefore quickly the burning will be taken place. No, it is not correct. It is not correct. Why? Because when you are pumping more amount of air, then automatically all the heat will be taken by the air itself and will go in the flue gas, not to the system, not to the water. Okay, that's a very important problem. So you need to properly optimize the speed of the forced draft system. Hello? 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 Somebody's opened the mic. Who is that?
Yeah, it's been muted, sir. Please continue.
So when you pump more amount of air, then automatically the heat generated by the fuel or heat generated by the system will be completely taken by the flue gas. So you must be very careful by monitoring the temperature. When the temperature is very, very higher, that means your flue gas will take more amount of heat. That is completely wasted. You are burning the fuel, taking the energy for heating the water, but burning the fuel, taking the energy into the flue gas, and through the flue gas, you are wasting the energy. Okay, so you need to monitor the flue gas temperature. That's very, very essential. Also, you need to monitor the color of the flue gas. Sometimes it is a pure white, sometimes it's a very black. Sometimes you may require it may be a light pearl color gas output. Okay, so the color itself indicates that whether the combustion is going to be very proper or improper. Okay, number one. Number two. Suppose if your air is not sufficient, what will happen? That's another important question. So if the air is higher, what will happen? The heat generated by the heat produced by the fuel is taken away by the flue gas, correct? But when the air is not sufficient, what will happen? When the air is not sufficient, then automatically oxygen is not sufficient. What will happen? So the combustion will not take place. That means the combustion is not 100%, it is partial combustion. When the combustion takes place correctly or partial combustion takes place, then your hydrocarbon content in the fuel will be not utilized. The energy is not completely released. Rather, it releases CO. It releases the carbon. So more amount of if the fuel is not properly burned, then CO will be released. Carbon monoxide will be released. So that will again pass on to the flue gas, the chimney, and the smoke color is completely black. Okay, so the color indicates a very important point. So smoke color is black means then that is an indication for insufficient air, sufficient combustion. Okay, so that means you need to pump more amount of air now. So that is why the flue gas monitoring is very, very important. So most of the industries, those having a boilers, they will regularly check the flue gas. So what is the temperature of the flue gas? What are the content in the flue gas? We have a separate flue gas analyzers are available. I show you in the yesterday class. So in the flue gas, what is CO, what is CO2, what is O2, what is the excess air? So everything will be properly monitored and measured with the help of a flue gas analyzer. So two things you have to remember. Number one, the forced draft fan should pump the air very sufficient quantity. When it is higher, problem. When it is lower, again problem. Okay, now this is for the first case. Second case, now you produce the steam, no problem. You produce the steam and you let out the steam to the process. Now the process require the steam is, let us assume that the steam is at 8 bar pressure or 7 bar pressure or 6 bar pressure. Now the steam is going to the process. The steam boiler is in some barrels and the steam will be in some barrels. Okay, so steam replacement is some barrels. Now you are let out the steam and that will be going to the boiler. Sorry, going to the process. Now the steam will have a very higher energy content. Now it is in the gaseous state. The piping system for carrying the steam should be properly insulated. It should be very, very insulated. So the outer temperature of the pipe should be almost equal to your ambient temperature. It should be. But practically it's not possible, but it may be around 30 to 40 degrees, maybe higher. Or very approximately, very correctly speaking, it should be 20 to 30 degrees higher than your ambient temperature. If it is more than that, then automatically your heat content available in the steam will let out to the atmosphere. What will happen when the atmospheric it touches the atmospheric air? Then automatically atmospheric air will or atmospheric temperature will have a moisture content. So because of that one, automatically your steam starts condensate itself. Before going to the process itself, the steam starts condensate. So water droplets will be developed in the pipe. So when the water droplet goes inside the pipe to the process, then the process will be affected. Quality of the process will be affected. Okay, so something similar to your compressor. In compressor air, water should be properly let out with the help of a drain valve, or you have a dryer, or you have a separate drain valve system in the pipeline itself. So likewise, you have some equipment also available to let out the water developed inside the pipe, inside the steam pipe. Okay, now it should be properly insulated and it will be go to the process. Okay, let us assume that I'm using the steam for my process either directly or indirectly. Okay, now after my application, now the steam start condensate. So because I'm taking all the amount of energy for my application, for my process. So what will happen? My steam starts condensate and it will become water. Now, what will happen to the water? Whether I can keep the water there itself or I have to pump it back to my application. Because if you have a condensate water is in the approximately it is in the temperature of 80 to 90 degree, which is very, very higher. Temperature is very higher. So you can reuse it for your application, because if you are having a water can be heated up. Let us assume that the water is in the atmospheric ambient temperature. Ambient temperature is 35 degree. Then you require your amount of fuel to heat up from 35 degree to 100 degree. So you can see how much amount of energy you require to heat up the water from 35 to 100 degree. Rather, if you take the condensate water here, because that is already in a very higher temperature, maybe around 70 degree, 80 degree, or even 90 degree also. So if you pump back the process, condensate water from there to your feed water tank, definitely for this process, the temperature will come down. Okay. Assuming that 10% is the temperature loss. So at the point of condensate, the temperature is going to be 80 degree. So you are taking the condensate water to your feed pump. So feed pump, when the 80 degree will become 70 degree. No problem. You can mix up the water with your already existing water. What will happen? The existing water is in the ambient temperature. Now you will mix up the 70 degree condensate water. So what will happen? The temperature of the feed water tank will improve. Correct? Temperature of the feed water tank improve. So assuming that it's a 35 degree earlier, now you mix up a 70 degree of condensate water of huge quantity. Then it may increase to 55 degree or 70 degree or 60 degree or 70 degree, whatever it may. Now, what is it advantage? Yes, it is a very, very huge advantage. Why? Because earlier you are increasing your water temperature from 35 degree to 100 degree. Now your inlet water itself 55 degree or 60 degree. So you require a less amount of fuel. Less amount of fuel is required to heat up the water because already it is heated up. So this is a very, very important essential energy saving measure for the boiler. So condensate water 100% to be returned to the feed water tank. Number one. Number two, when you take the condensate water, that water pipe is also insulated. That's another important point. I saw recently one industry in Udmalpet where they have a 100% condensate recovery. But only thing is, some of the places they do not have the insulation, especially for the bend and cross, where they do not have the insulation. Actually, they have an insulation, but it was worn out, but they didn't replace it. So because of that one, when the insulation is not there, then automatically what will happen? The temperature will go out. When it's in the normal pipe, then automatically the temperature will go out. So then that will reduce my feed water temperature. So the insulation pipe, the condensate pipe should be also insulated, and the amount of energy loss, temperature loss should be as minimum as possible. Number 2. Okay. So this is another important heat recovery system. Okay. Second, this is the second point. Third point. Now your flue gas will be taken out. Okay. Now this flue gas will not normally go out. Actually, when you heat up the air, then the density of the air will become lower. Then automatically it goes high. So because of that one, naturally it goes out. But you have a separate motor, a separate fan that is called ID fan. So FD fan is used for pumping the air inside the chamber, whereas ID fan is an induced draft fan, which is mainly used to take the heat air to the chimney. That's called ID fan. So you don't confuse with an FD fan and ID fan. ID fan is used for, FD fan is used for pumping the air, whereas into the chamber, whereas the ID fan is going to be used for taking the hot air to the chimney. Okay. Now that ID fan is keep on, again, it's a blower. It's not a fan. So it's a blower. Of course, it's going to be a fan. Okay. Now that fan will take the heat out and then will go to the chimney. This very important point. Very important point is this air will have a heat. The temperature of the air, the temperature of the flue gas is going to be more than 180 degree or 190 degree, 200 degree, or even for this example, you have a 250 to 280 degree. You can see this is very huge. You can take some amount of heat. You can take some amount of heat for your application. So that's called waste heat recovery. So where we are using the economizer, we are using some economizer. What is economizer? We are using economizer very simple. We can take the heat from here by putting a separate pipe here. Okay. So in that pipe, the feed water goes inside the pipe. Let us assume that it's a spiral pipe in the duct, in the FT duct, like this. It is available. Okay. So in the spiral duct, in the spiral piping system, inside the piping system, if you flow the water, feed water, and it will flow through this piping system, and it will get the heat from the flue gas. Automatically, the temperature of the water will increase. Now that water will be given as a input to the boiler. So what will happen? You are reducing the flue gas temperature by passing the heat available in the flue gas to the water where it is used for feed water. So this is an economizer principle. So most of the cases, economizer will be always available. If it is not available, it is recommended to put an economizer. That's a very simple case. First important point. Second important point, some of the industries will have one more arrangement. Suppose if they are using firewood, what will happen to the firewood? Normally the firewood should be pulverized. It should be cut off and should be having a more amount of pulverization. But 99% of the industries are not using pulverization techniques. They don't even cut the wood and put it in the fire chamber. So what they are doing, they put the complete piece of the wood into the chamber, and it will take more amount of time to reach the temperature. So when the temperature is not reached, what will be done? The boiler operator will feed more amount of wood inside the chamber. So ultimately, the number of fuel consumption will be increased. Okay. So now it is recommended to pulverize the wood, or at least you can cut the wood. It has two advantages. Number one, if you cut the wood and keep it for at least some time in the atmosphere, the amount of moisture inside the wood will be taken out. Number one, when the amount of the moisture will taken out means automatically easily it will burn, and it will release the amount of energy very quickly. Number one. Number two, if it is cutted, then automatically more amount of burning area you can get it. Suppose if you have a round piece, of wood, then the burning area is going to be only in the outer periphery. Rather, if you cut the round piece into two halves, then your burning area will be higher. You can see one half, and inside the wood, and see you have one more half. Again, you can have an inside. You have one more area. So burning area will be increased. So quickly it will burn. Quickly it will give the temperature. So that is an added advantage for the boiler. Okay. So in boiler, we can tell n number of energy conservation proposals like this. And third important point, you can take the flue gas, filter the flue gas, because sometimes some ash will also come out. You can't able to directly use the flue gas for your application. Okay, so you can filter out the ash. Okay, now that air will be passed on to the fuel because it's a hot air now. If you pass on to the fuel, particularly wood, what will happen? The moisture content will remove. So that can be again used as a fuel to the chamber. When the moisture content removed means automatically it will quickly burn and it will reach the temperature, and that will also save energy. So in three different ways, you can take the energy conservation. Number one, you can take the flue gas and heat up your feed water, that is called as an economizer, and take the flue gas and you can use the flue gas, pass on to your wood, that will remove your moisture, and you can use the flue gas for heat your air also. The incoming air here, incoming air with the help of an FD fan, that also you can heat. That's called as an air preheater. There is a separate equipment called air preheater, APH. So you can use this flue gas heat to preheat the air. That also very important because we need a temperature, the 3T, 1 T is a temperature to be put inside the chamber. So that's another point. Always we will keep remember, right? This is called APH, air preheater. Okay. Now we move on to the performance of the boiler. Normally, performance of the boiler can be evaluated by two important parameters. One is an efficiency, another one is an evaporation ratio. Whereas efficiency calculation will have two different cases. One is a direct efficiency method, another one is an indirect efficiency method. Of course, indirect efficiency method is somewhat complicated, but it is accurate. Whereas direct efficiency method is simple, but it is not accurate. It will give only an approximate value. So rather efficiency point of view, people go for an ER. Evaporation ratio is one of the parameter. Okay. Now evaporation ratio can be easily found out by simple formula: how much amount of quantity of steam produced divided by how much amount of quantity of fuel. You can use it. Very simple, very simple measurement. You can calculate the evaporation ratio. This ER value, now this ER value is different for different type of boilers. You can see if it's a biomass fired boiler, the evaporation ratio is going to be between 2 to 3. If it is going to be coal fired boiler, it is between 4 to 5.5. If it's an oil fired boiler, it is between 13.5 to 14.5. If it's a gas fired boiler, it is 11 to 13. Okay. So with the help of this chart, you can find out whether your boiler is properly working or not. Okay. Now let me come to the point of this elaborately, how to calculate this evaporation ratio. I can easily calculate the quantity of fuel input. How much amount of kg per hour for 1 hour? How much amount of fuel I input put in the chamber? I can able to measure with the help of a digital weighbridge. I can measure. This is very simple. You can give a digital weighing machine to the operator and ask him to measure how much amount of wood you are putting inside the chamber for 1 hour and record it. This is very simple. But how to measure the quantity of steam produced for 1 hour? That is another simple another point we will discuss. Instead of measuring the water, instead of measuring the steam, we can able to measure the water because water and steam almost will be same. Okay. Normally, bigger type of boilers, steam flow meters are available. How much amount of steam flow is can be easily measured with the help of a steam flow meter. But it is somewhat costly and also somewhat cumbersome to fit the steam flow meter in the pipe. Rather, you can see how much amount of water you are taking. So that water is going to be almost equal to your steam production. Assuming that 100%, not 100%, is going to be almost 99% steam production will be equal to your water. So again, for water, you can fit a water flow meter in the feed water tank. So in the boiler, input of the water point, you can put a water flow meter, which is available. Normally which is available in your home. In your home, if you have a corporation water, there is a meter will be available, which is keep on rotating. If you take the water, automatically keep on rotating, and it will show how much amount of water you can take. So for 1 hour, how much amount of water you are feeding into the water feeding into the pipe, sorry, into the boiler, that can be measured. For example, it may be around 1000 kg or 1000 liter. Of course, kg and liter are same for the water because specific gravity for the water is going to be 1. So therefore, the volumetric value and mass flow value is going to be same for water. That's why water is taken as a benchmarking value. Okay. So 100 kg, sorry, 1000 kg or 1000 liter of water per hour is taken, and 250 kg of fuel is taken. So 1000 divided by 250 equal to 4. So it's a very simple. So measurement of water, measurement of fuel, which will give the evaporation ratio. So 90% of the industries should do this exercise. But as far as our experience, even 20 to 30% of industries are not doing this practice. But keep remember that some of the industries are regularly doing, even daily they are doing, even shift wise they are doing the evaporation ratio. So this is another point always we have to keep remember. Suppose if the evaporation ratio is going to be not good, what is the meaning of that? Suppose the desired value, you can see the desired value is going to be, if it's a coal-fired boiler, the desired value is going to be 4.4 to 5.5. Say for example, it's going to be 3 for coal-fired boiler. What is the meaning of that? What is the meaning of that one? If it is going to be 3 means, you are consuming more amount of fuel. Am I correct? Because this is a lesser value. For producing the same amount of steam, you are consuming more amount of fuel. This is the first important point. Suppose if it is a very higher means it is inevitable. It is not possible. It's not possible. More than 5.5 is not possible. So there is a problem in measurement, whether in the fuel or in the steam, you are not having a proper measurement. So by measurement, we can come to a conclusion whether your system is correct or wrong, or your measurement is correct or wrong. That we can able to find out. Okay. Then the second parameter is an efficiency. Efficiency calculation is going to be again it's a very simple output of the energy output divided by the energy input multiplied by 100. So what is the energy output? It is a steam heat content in the steam and heat content in the fuel that can be represented in terms of the kilocalorie, and again fuel content in kilocalorie multiplied by 100. Steam content in kilocalorie can be taken by the from the steam table. Okay, so at what pressure, at what temperature you are producing the steam. So based on that, the steam energy content of the steam will be taken from the steam table. And the fuel energy content, already I show you in the previous slide. Wood has its own energy content. Furnace oil, coal, or whatever maybe has its own values. So based on that, you can calculate the efficiency. Is an indirect method. So indirect method is different. This is somewhat cumbersome, but it requires a manipulation measurements also. Okay. So normally the boiler efficiency for a wood-fired boiler is going to be around 60 to 70%, whereas coal-fired boiler is going to be 75 to 80%. Oil-fired boiler is going to be very higher, but it requires more amount of maintenance. Similarly, evaporation ratio is going to be like this, and the fuel cost is also represented. Steam cost. This is the older value, not newer value. Okay. Now, what is the data to be maintained? Or condition monitoring of the boiler regularly you have to take place in the system. So you need to monitor the fuel rate and the loading percentage of the boiler, evaporation ratio, flue gas temperature, how much amount of excess air you are passing to the chamber, normal air plus excess air. Excess air to be always passes, so that you need an oxygen value. We are having only 21 or 22% of oxygen in the 1 kg of atmospheric air. So you require more amount of air to be passed out to the chamber, so that the the required amount of oxygen can be taken. Okay, these are all the instrument which is going to be used for measuring the system. Surface temperature of all the boiler equipment that can be given by the IR gun or IR thermal imager. Right. Now these are the area where you can use to monitor the system and energy saving possibilities. I told you we have an excess air control with the help of an FD fan. Forced draft fan can be operated at a variable speed operation. So FD fan with the VFD drive, which will give a correct air combination or air combination to the fuel. So that can possibly save the air. Automatic blow down. Blow down means it's very important. Your air, so your water, not normally used for the boiler, should be DM. Should be DM water. Normally it should be a modified water, because the salt content in the water should be within the limit TDS value, salt content, pH value, everything is going to be very, very important. See, operating the boiler is not a simple one. Maintaining the boiler is not a simple one. So sometimes most of the cases they have a separate RO plant. Sometimes they have a separate DM plant also available. Okay, so that DM plant water to be given as an input. Okay, now if you heat the water and start producing the steam at one stage, the water available inside the boiler, the TDS level is going to be keep on increased. So when the TDS level is going to be keep on increased, you should take the water out and you should not use the water. You should not use the water, and you can take the water out and you can add the fresh water. So that is called blow down. At regular interval, you can take the blow down. Blow down means you can let out all the water, almost all the water. Not all the water means at least 60%, 70%, or 30% water based on the TDS level, based on the total dissolved solids in the system. What will happen if you are not doing the blow down? If you are not doing the blow down, the scale formation will be taken place. So when the scale formation taken place, then the heat transferring is going to be blocked. So the amount of heat generated, amount of steam generated will be lesser. So that will affect the efficiency of the boiler. So regular blow down, automatic blow down will be also taken care by measuring the fuel value, right? Then feed water heated up with the help of an economizer or some other means. Even some I saw one factory, they're using a solar water heater to heat up the water from ambient temperature to nearly 60 to 75 degree. Then condensate water is also available. So they will feed the water nearly 85 to 90 degrees temperature to the tank. So what is the advantage? You need only 10 degree to heat the water to become a steam. So that's another advantage. Okay. Now similarly, optimize the pressure of the steam wherever required, whenever required. You can optimize the pressure. Then only you can operate the boiler at very optimal level. Then waste heat recovery from the flue gas. Then the conventional and radiation losses outside the boiler, outside the heat chamber. So these are all the area where we can work out in the reduction of losses. Then the energy efficient boilers, energy efficient motor, where we are using 3 types of motors for this. We are having almost some electrical parts like water feeding can be taken by water feeding pump. So that pump will be an energy efficient pump. Then you have an FD motor. FD motor is an electrical, so which will pass on the air. That should be an energy efficient motor or energy efficient blower with VFD control. Your ID fan will be also a energy efficient motor, and that should be again taken care by a VFD if required. So these are all the area where I can save amount of energy. Okay, so this will give the way in which the system is working and monitoring the flue gas system and excess air control system, and where you require the boiler operation of the entire system. Then you can have an automatic automatic TDS level monitoring system normally available, but most of the small boilers they are not using. They will monitor by manual and blow down the system. So if they are not monitoring, they will blow down by every shift. So that is a thumb rule they are normally using. Then set pressure optimization. If you are operating the pressure at nominal level, then you will have a very good savings in the systems. Then you can measure the flue gas at the flue gas point, and if the temperature is going to be very, very higher, then you can reduce the temperature either by using the air preheater or water preheater or economizer, and you can optimally load the fuel. So that will also have a very good impact. So by every 22 degree reduction of your flue gas temperature will save 1 unit of fuel in the system. Then you have a good savings in the economizer. I told you the economizer, almost 99% of the boilers will have an economizer. The heat available in the water, available in the flue gas can be taken to the boiler feed water tank, or a small pump will circulate the water through this duct of the flue gas, and the amount of heat taken by the water will be given to the feed water tank. Then the losses almost completely you have to enclose it. you have an aluminum cladding. And apart from that, you can inside the boiler, you can have a ceramic bricks are there. After insulation, when the insulation is failure, then automatically the heat will come out. So that is a huge loss. So keep remember that insulation should be very pakka, so that you will always measure what is the temperature all around the system, not only the boiler, all the auxiliaries also you have to measure after insulation to be ensured. Okay. So this is the conventional system. This is the 2 days burner. Okay. So I think we can stop at this point. Sir, I think we stop at this point. We can have some break. Madam? Hello?
Yes, sir, sure.
Madam, the time is 25. Is there any
Okay, a
question?
10 minutes break would do, right?
Is there any questions? Hello? Is there any questions? Madam, there is no question, huh?
No, Dr. Sivarasu, I don't see any questions in the chat box.
Oh, okay. Hey, madam. Okay, we will have a break and we will come back by another 10 to 15 minutes. Thank you.
Okay, thank you.
And is it visible? Hello?
Yes, sir.
Okay, thank you. Welcome back to the second session of day 3. So morning we discussed about how to generate the steam. Now how this steam can be utilized for a process application and how it is effectively used. And after usage, how it is, how effectively it condensate, and how effectively take it again back to the system. So many things already discussed, but only thing is additional perspective we will discuss. Steam distribution system, we need a process steam distribution system which includes generation, distribution, end use, and a proper recovery. Now you can see the piping system available here. Piping system which has very pakka insulated. So inside the chamber of the boiler, inside the chamber of the system, everything is insulated. Likewise, the piping is also properly insulated. Otherwise, heat will escape from the steam. So when the heat escape from the steam means automatically starts condensate the pipe itself. So water droplets will be always available. So that should be avoided. Should not go the water, only steam, not the water. Okay. Now the steam will be measured in terms of its dryness. Okay, the dryness factor. Dryness factor indicates that how much amount of moisture content available in the steam. So if it is an 85% or 90% or 95% or 65%, that means when the steam is 85% means 15% moisture content is available. So you may have a dry steam, not the wet steam, to be in the process. So the wetness should be properly taken out. It is not avoidable, but it is minimized. It can be able to minimize. Number one. Number two, and if the water droplets are available in the pipeline, that should be properly taken out. It should not go to the process because that will affect the process. So my requirement is only steam, not the water or the hot water. Okay. Sometimes this water will create a rust in the system, rust in the equipment, rust in the process, or affect the quality of the system, especially for the food industries. We went to one industry in Bangalore. They are manufacturing the turmeric powders. So for that, they are using completely saturated dry steams. And they have a multiple arrangement to take the water out, from the steam. So you need a very proper cladding system, and that should have a very pakka insulation. Sometimes, mostly it is ceramic wool insulation, which is a rounded outer periphery of the pipe and completely surrounded by aluminum cladding like this. At each and every point, you should always check the temperature at regular interval. Then sometimes you require a valve. So these valves are also important. So basically, the flow of the steam and the pressure of the steam is completely controlled by the valve. Why? Because you are producing the steam at 7 kg or 8 kg or 6 kg. But your process may require 7 kg for one application, 3 kg for some other application. So what can we do? Can we have two different boilers, one at 7 kg and one at 3 kg? No, it is not correct. Rather, we can use some valve. That's called PRV, pressure reducing valve. That will reduce my pressure from 7 kg to 3 kg. And you can take a separate line for the 3 kg pressure. So these valves and the regulating valves are mainly used for regulating the flow as well as pressure. Mostly pressure, but flow also regulated. So this valve also to be taken care, because sometimes it's a mechanical component, sometimes there is a weakness in the system, there is an ambiguity in the system. So automatically, because of that one, automatically the steam loss is going to be taken place. And finally, we can have a steam trap. I told you the water droplets will be always available because of the condensation of the steam. So the water droplets will be properly collected by an equipment that's called as steam traps. Okay. When it is not collected properly, then automatically what will happen? The quality of the steam will be affected. That is why the steam traps are regularly located at regular interval. Normally in an entire pipeline, with the help of a distance, or based on the pressure, based on the flow, the number of steam trap lines are proper should be fitted to collect the water and let out in the outside, or it will be in the connected to the condensate system. Okay. Now this is a very simple example where we can have a steam line will be always available when it is a water available means there is a small floating wall. When the water is higher, then automatically the floating wall is open, then the water came out. Okay. Once the water came out, then it starts closing. Right. So when the water again available, then it will start moving in this direction. Let open in the wall, then water will go out. So this is mainly used for enhancing the quality of the steam. Okay. Now this figure will show you this figure will show you the steam distribution system, something similar to your air distribution system in the compressor, where we have a steam distribution system in the boiler, in the boiler section. Okay. So now compressor will produce take the atmospheric air, compress it, and give it a high pressure air. Similar fashion, the boiler is also same thing. It takes water and use the fuel to heat up the water, generate the steam, and steam can be used for process application. Okay, now the steam is boiler is here, and boiler is operated with the help of monitor with the help of pressure inside the boiler, and the steam will go out, and the pipeline also will measure the pressure. Okay, I told you wherever if you go the pressure pipelines, automatically the pressure drop is inevitable. There are so many reasons are available for the drop. Number one, the system itself has some resistance, so because of that one, the drop will be occurring. Number two, you are using for your process. So when you are using for the process, automatically pressure drop will be available. So if you measure the pressure here and pressure here, then definitely there must be a drop. Something similar to your voltage drop in the equipment, in the line. So let us assume that I have a 100 meter line. So in the 100 meter line from the supply to the lower end. So in between that, I am taking four equipment. I connect 4 equipment. If I turn on one equipment, automatically the voltage drop is going to be inevitable. So same way, if I have a process, if they turn on the process is replacing my steam, then automatically the pressure is going to be slightly reduced in the outside of the first process. So normally the higher pressure is available here, slightly lower pressure will be available to the second process, and the entire steam length, the pressure should be optimized. Okay, we can't able to avoid the pressure drop, but it should be minimum. Okay. Then once you use the steam, then whether it's going to be direct heating or indirect heating, then automatically it starts the condensate, and the condensate can be properly taken with the help of a pump or traps. Sometimes you have a traps, and trapping system also let the water, and water will be connected to the condensate return pipe. Okay, now you see the condensate will have a trap, the process will have a trapping system. Condensate recovery, we have a separate pipe, and that should be again connected to the condensate system. So in that way, we can have all the condensate. You see the brown color is a steam line, and blue color is the water line. Okay. Now the water will be again condensate water will be available here. Now that can be connected to your receiver, your tank. Okay, condensate collection tank. So from that you can again take the water with the help of a high speed, high temperature pump to your feed water tank, because this feed water will be given as an input to the boiler. So if you properly collect all your condensate, then definitely your feed water will be increased. That will reduce your fuel consumption, right? Sometimes you can have a flash steam also, that is not required for this this event, because that may be sometimes going to be. So you have a steam traps also available. So steam traps, I told you to collect the water in the system. So we have a different type of steam traps are available. You have a thermodynamic steam traps, bimetallic traps, flow type. I told you the previous picture, flow type, and similarly mechanical trap, bucket type trap. So when the steam start condensate, the water will be go out like this. Then this is the steam in the main pipe and the floating trap valves, different type of floating valves. How it can be. So see, you can see the steam traps. So normally a small amount of downward pipe will be always provided for your in the main line. So in the main line, if the water comes out, and that will go like this, and when it is higher, then it start open, then the output, the condensate will be come out from the system. Okay. Now you can see the steam distribution line. Of course, it's going to be almost same, but only thing is in a different perspective, without the condensate water and with condensate water. So this point already we discussed, but in a block diagram way, I have a pump can be used to pump the feed water to the boiler. Now the feed water tank temperature is going to be 35 or atmospheric temperature, ambient temperature. I'm adding the makeup water. Okay, so I have a two type of water coming to the feed water. One is a makeup water or additional water. Then the second one is a condensate water. Now the steam can be flowing to the application. After application, the steam start condensate. And the condensate water, I didn't use it. Right? I didn't use it. Rather, if I use the condensate water with the help of a heat exchanger, I can take the water. I can take the heat and I can use it for my feed water tank. 35 degree will increase to 65 degree. So automatically 30 degree is going to be an increased temperature. So how much amount of fuel you can able to save? Again, it's going to be very simple. Mass into Cp into delta T. So earlier you have 35 and the maximum temperature is 100. 100 minus 35 into Cp equal to 1 because it's a water into the how much amount of mass is required to put the water to produce the steam fuel. Now it is 65. So 65 minus 100 minus 65. So therefore the mass value will reduce. So this will be a huge saving for us. Okay. Now steam traps, already we discussed this point. What are the types? How it is work? This is the flow of steam. We have a metallic cage, incessant pipe. We have a strainer. So in that it will be flowing out. When it is fill out, the pressure will be developed, and because of that pressure, it will start pushing this valve, automatically start releasing it. Quite for 30 to 40 seconds. It will quickly release. Then again it will close because all the water will be released. So it will be closed. So in the steam distribution system, these are all the points to be always monitored. What is the condensate return? Where I have to monitor, I need to monitor the feed water tank. How much amount of condensate is going to be returned? Normally 70% of the water will be returned. 70% of the steam will be returned normally. So 30% is the makeup water. It depends on the process. Again, it depends on the process. Depends on how many equipment using the steam, and also whether it's a direct process or indirect process. That will matter. But mostly the condensate water recovery is going to be very higher. That's why it is represented here is going to be 50 to 70%. So your makeup water is going to be only 50 to 30%. 30 to 50% is the makeup water. Okay. Now the leakage should be always measured. Leakage in terms of steam pipeline, leakage in terms of condensate pipeline also measured. So that should be only 5%. And again, it should be carried out by the visual inspection. Trap functioning should be always measured. This is very important because when the trap is not properly working, what will happen? Then the water will flow inside the pipe, sorry, inside the steam pipe. Automatically, that will affect the quality of the system. So you have to regularly check the trap. Probably by weekly you have to check the trap with the help of a thermography gun, or sometimes screwdriver can be used for visualizing is there any hammering effect available. Then worn out insulation. This is again visual inspection. When the insulation is going to be failure in the boiler system or steam pipeline or whatever may be, it should be properly inspected and that should be rectified. Then percentage of the makeup water should be daily monitored and daily measured. Then maximize your condensate recovery. How much amount of water you are feeding input, and how much you are taking you recover. That is the very important part. In case if you recover more than 50% or more than 75%, more than 80%, it is very good. So we insist to take the initiative to recover the condensate value at the maximum, because that has a higher temperature, and you need a separate tank for condensate water, and that should be properly pumped to your feed water tank. Now this water is a very high temperature, so therefore the pumping system also will have a very proper high temperature materials. Otherwise, the pump will failure. Okay, insulation will failure, piping system will failure. So automatically you need a very good recovery system, steam recovery system. So it is accessible that the present condensate recoveries for this example, assessment is going to be taken for 40 to 45%. So if you are about 10 tons or 10 kL of condensate can be potentially returned to boiler at 80% temperature, which can be used for hot water for 50% of the washing machine. Sometimes it can be given as a feed water, or sometimes the hot water can be used for some other application like washing machines or for leather washing applications in some industries. Okay, so you need not produce a separate system for producing the hot water. The condensate water itself acts as a hot water. Okay, so in that way you can take the energy from the system. Then avoid the leakage of the steam. Similarly, in the boiler, in the steam distribution system, something similar to the leakage of your compressor air. Something same is going to be applicable here. Okay. Now, steam wastage can be indicated. There is no separate meter is available. Of course, recently one company came out with a sonic analyzer. So they will use this sonic analyzer to find out the steam leakage, but visually we can find out the leakage. Okay. Now you can see the leakage size, the pipe size. We have a 1.5 mm small hole in the pipe. The annual amount momentary loss in terms of money. For example, if the cost of the steam is going to be 1 rupee per kg, okay, at 3.5 pressure, at 7 bar pressure, this is the amount of money you are wasting, because you are producing the steam by giving energy, by giving money, by giving manpower. So if you are wasting, then automatically the cost is going to be wasted. See the very important point. You can see the diameter is going to be 6 mm. 6 mm. It's going to be very 6 mm. The cost loss is going to be 7.4 lakh rupees. Per annum. It's a very huge amount of money, almost equal to a one man's salary. So the losses to be properly accounted, and it should be very carefully arrested. So yes, a team should be always engaged to identify the losses in the piping system. Okay. Similarly, the pipe length increases, then the steam losses is also increases because of the length of the pipe, and similarly for the leakage probabilities are also higher, because you are using sometimes you are using the PRV valves, you have a flow valves, PRV. So in that automatically, definitely there must be a small leakage. Not now, after some time, 1 year, 2 years, or even 5 years later, definitely always leakage will be available. That is why you have to monitor the pressure with the help of an indicator meter, and similarly you have to also check whether the visual leakage will be available or not. Okay. And similarly, insulation is going to be another important factor where you need to find out the insulation is going to be very pakka or not. So piping system, pipes should be properly insulated. Not only the piping system, the flanges, pipe, the valves, everything should be properly insulated. But most of the time, pipes are properly insulated, but the flanges are not properly insulated. Valves are not properly insulated. This is not really happened. Why? Because they told that sir, we have to regularly check the functioning of the valve, so therefore we are not insulating it. No, it is not correct. So you need to properly insulate your valve also, your flange also. So that is why we have a separate system called like this. You can see this is a detachable one. So earlier I am having a valve, a pressure reducing valve, which does not have an insulation. Now it is covered with an insulation. Now this can be detachable. When you want to check the inflow and outflow measurement, or when you want to check the screwdriver measurement, when you want to check the thermography image measurement, before and after, you can remove it and you can do the measurement, and then after that you can put it. Okay, so this is one kind of savings. Let us assume that you have a 10 number of such valves are available. So because of that valve itself, you have a huge amount of losses will be taken place in the system. So steam pipeline should be properly insulated. A steam pipeline of 1 meter with uninsulated steam and valve, there is a problem. You can see the heat loss through the steam valve is 5 times the heat loss through 1 meter steam pipeline. And similarly, the heat loss through the flange is equal to 3 times the heat loss in the 1 meter steam pipeline. So it is measured like this. There is another perspective is available now in the industry. Instead of doing this type of insulation, they are having a separate paint called TCC paint, thermoceramic coating paint, that can be painted on the valve, which cannot allow the heat to escape from the valve or the flange. And this paint can be holding capacity of 1200 to 1500 degree. Of course, we are operating the steam at 180 or 200 degree only. So if you put the paint on the valve or on the flange, automatically the temperature in the outside will be get reduced by minimum of 50 to 100 degree maximum. So that itself is going to be good saving. Rather going for this type of insulation, we can go for a TCC painting application. So TCC painting application not only for the flanges and pipes, it can be also used for other areas like this. If you have any problem with the insulation, you can put the TCC painting system. Only thing is it can be having a life of maximum 2 years. So after 2 years, it will burn out. Again, you have to do the painting. And similarly, the cost of the painting is going to be very lesser per square meter. The cost is going to be very lower. And so many people are available now having a material of TCC, and they got a good savings in the boiler, hot water generator system, hot air generator system, and so on. So therefore, I recommend to go for a TCC painting in case if you have any difficulty in the installation for the systems. Then the best operating practices are very, very important. So these are the tubes I told you now. These are the tubes, fire tube or boiler or the water tubes. Inside the tubes, the water will go or the fire will go. Inside the tube, if the fire will go or water will go, definitely the soot formation will be available. Scaling formation or soot formation is always available. If you are passing the fire, automatically soot formation is available. If you are passing the water, the scale formation is available. At regular interval, you have to clean it. Otherwise, what will happen? The heat transferring medium will get blocked because of the soot or because of the scaling. So heat transfer is not takes place between the fuel and your water. So operating practices for the boiler is a very huge list. Okay. So at regular interval, you have to go for a blow down. At regular interval, you have to remove the soot formation inside the tubes, and at regular interval, you can go for some chemical arrangement, chemical treatment for your boilers. And similarly, not only the system flue gas chimney also you have to clean it, because whenever if the chimney is not cleaned, means automatically the flue gas, the carbons are deposited on the flue gas chamber, so that will not allow you to go the flue gas outside the chimney. So that will again block. Chimney will heat it up. So many things are available. So soot formation is going to be one of the important parameter, and that should be built on the tube and reduce the heat transfer rate, which removes regularly. Probably in a weekend or every week or 50 days once, you have to properly clean it. So high flue gas exit temperature is the indication of the soot formation. It's a very simple idea. When the flue gas temperature is going to be very high, then automatically your boiler in the tubes, pipes, you have a soot formation is going to be available. So that is a simple indication. And gas side soot formation requires soot blowing system. That means you have to blow the air, and that should be taken out. Soot blowing require when flue gas temperature rises by 20 degree for a new boiler and to remove it. And similarly, for soot blowing is done by exterior with steam. Sometimes steam also is the wastage of steam, but should be done as a energy loss may be saved. Very important, oftenly you can use a good quality of water, and water should be, if it is a water tube boiler, if it is a water tube boiler, the water quality should be very properly maintained. And most of the time, they will regularly check the water quality. as per IS 10500. So they will check the quality of the water by checking the TDS level, pH level, hardness, and other basic parameter like odor, smell, and all those things. And most of the time they are using DM water or sometimes RO water also. Because of that one, the scaling formation inside the tube will be lesser. Again, best operating practices for the steam distribution line is very proper material and very proper installation. Installation is also very important. The piping system should have very correct size piping. When the size of the piping is going to be very bigger, then pressure drop will be available. When the pipe size is going to be very smaller, then flow rate will be affected. So in either case, you have to properly design your piping system. So ensure that your proper sizing to be maintained for correct speed or correct flow or velocity in the same system. Similarly, steam trap installed at regular interval at lower point, not in the main pipe. This is the main pipe. So this is the point where mentioned for only steam traps. So at regular interval, you have a downward points will be always available for steam traps. And that should be very properly checked and should be given attention. So steam trap should be installed at a low point like this, and diversion of the process. We have a diversion. This is a T connection, a diversion of the process in the same system. And you can see the steam and condensate piping should be checked periodically and repaired, because if there is any problem in the steam, similarly in the problem in the recovery rate of the steam condensate, then that would be the good indication for saving the energy. And physical verification of the data also should be there. Okay. Then sometimes you can install the flow meter, but flow meter measurement is going to be somewhat costly. I don't know. I mean, I saw most of the companies are not having the flow meter, but they have a pressure meter. But they will do the audit with the help of a flow meter, and they will check the flow meter, the flow of the steam as well as flow of the condensate. Okay. Now we go for the next topic of the steam system. Is the thermic fluid heater. Of course, this is for the afternoon topic, but we have a time, so therefore we can go for a thermic fluid heater now. Okay. Now, what is thermic fluid heater? And whether it is substitute to the boiler? Yes, absolutely correct. But in what way it is applicable, and what way it is substitute for the thermic fluid heater? Okay. Now this is the latest one, which will produce a very high temperature system, and this is purely working on the oil based. Okay. The efficiency of the thermic fluid heater is basically of 82% efficiency. Even sometimes it's going to be slightly more, but only thing is we need a separate oil system for this one. So instead of using the boiler, so this is going to be a somewhat economical, but only thing is the initial cost is going to be very higher. The thermic fluid heater TFH is now coming in a bigger way to replacing the boiler, especially for medium and low pressure applications. We are using this TFH. Now, the operating temperature is also even up to 300 degree, and this is going to be mainly used for producing the process application up to 300 degree. Then there is no need for flue gas analyzer, flue gas chimney. Even though we have the flue gas system is available, but not in the very bigger way. And similarly, you do not have a condensate recovery system. Similarly, steam traps, functioning of the steam traps, flash steam vent. So those things are completely not required for the system. We need only the energy content of the steam that can be used with the help of an TFH. Okay. Now, more economical than the steam for high temperature and similarly for low heat load applications. Okay. Now you can see this is the system where we have, again, this is going to be again closed chamber. We have a burner and the fuel is going to be an oil. This is almost something similar to the furnace oil. We are using this oil for the heated up, and because of that one, again the heated oil, this will be flowing to the piping system at very the high temperature, and this is going for the process plant and to all the area. Again, it is back. Okay, when it is processed, when the heat is transferred to the process, then it starts cool, then again it is back, and again it is used for our regular application. So it is returned at, it is flowing through 240° and return at 220°. Only 20° is the loss in the entire system. That means it is used for process, not loss. Sometimes loss also available, but it's a very, very small quantity. Okay. Now, only thing is the fuel is going to be an oil, so therefore it is keep on circulating in this way. It is keep on circulating. Only the heat up. The heat is going to be used for heat the oil. You use the heated oil to the process, and that process will get the heat from the system. Instead of steam, it is going to be a very, very good. So in fuel point of view, there is no require a huge plant or a huge system for storing the fuel. You can see the wood-based boiler, something similar to at least or half acre area is required to store the wood. So those things are not required. Only thing is you need an oil storage tank and some small area for storing the stock of the oil. That is enough. And oil also returned again back after the application. So therefore, makeup oil, similar to makeup water, makeup oil is also very lesser. So this is so much advantages, but only thing is cost point of view is going to be slightly higher. And similarly, retrofitting, replacing the boiler with the TFH is now taking way. Government of India, especially Bureau of Energy Efficiency, will give some incentives earlier. Now, not now. I don't know whether it's available or not. I have to check it. Whether replacing the boiler into TFH. TFH is going to be an almost a very modernized system where you can use this application. Now the same thing is going to be applicable. Instead of boiler, now it is going to be a TFH. Okay, now you can see there is no condensate in the boiler. So in the boiler, you are having a makeup water. Water is going to be available, and low down water is taken out. And we have a separate pumping system. So to condensate the water to the boiler, and we have a makeup water. All the water will be boiled out, will be given to the process, and process. Sorry, this is not boiler, this is the boiler process. And again, it starts condensing. So this is for operation. The main important point is high pressure requires to achieve same temperature due to low boiling point. More pump power required. Auxiliaries are higher. You can see there is a feed water pump, there is a makeup water pump, there is a condensate water pump. Then you have an ID fan. You can have an FD fan. These are the auxiliaries. Additional auxiliaries are higher in the boiler system. So because of that one, your more electrical power is required for operating the boiler. So therefore, more operating cost. So therefore, the steam handling, steam cost is going to be very higher than compared to the TFH. But only advantage is that steam handling is very easy than compared to because the temperature is going to be lower now. And also the pressure, of course, we have a controlling of valve is always available, but the steam handling is going to be somewhat lesser than compared to the heated up oil. You can see when the steam blow out in the system, it will also harmful, but compared to the heated oil, it is not that much harmful. Of course, this is having higher harmful effect. Now you can see the TFH. TFH is going to be a less pressure required to achieve the same temperature due to the higher boiling point. Boiling point is going to be very higher, so therefore it's a low pressure is going to be required. So therefore you can require only one pump or lesser pumping is required. You need only one pump to feed into the oil to the heater. So because of that one, the operating cost is going to be very lesser. And you can see your vessel requirement to store the thermic fluid heater is going to be the only additional cost, not the others one. Working fluid is flammable, and you have a special design for heating up the oil. Now, what are the data to be monitored if you have a TFH? Something similar to your boiler, same thing is going to be applicable for your boiler as well as your TFH. Okay. Now, what are the important parameters where I have to monitor, and what is the frequency of monitoring system, and what is the range of value? The range of value that depends on the site condition, location, all those things. Okay. Similarly, so I'm not mentioning very clear cut about the typical value of the ranges. Rather, all the 4 parameters like data to be monitored, where to be monitored, how to be monitored are very important. Okay. Similarly, frequency of the monitoring is also depends on the site condition. Similarly, the layout of the design. So we have an thermic fluid heater temperature, both the forward temperature. Forward temperature means output of the THF to the process, and return temperature from the process to the tank. That's called as a return temperature, 240, 220. Okay, like that. So it should be properly monitored with the help of a thermography, thermal imager or thermography, or even temperature gauges fitted in the system itself. So it is in the typical range of 250 to 290. Sometimes it could be 300. Every hour you have to monitor. Then fuel firing rate and what rate you are firing the fuel. So what pump, so fuel pump similarly for fuel feeder. So this is purely depends on the capacity of the TFH, also represented in terms of TPH. So by fuel meter and similarly for weight of the measurement. Circulating water pump and the motor loading percentage, normally it is 75 to 90 percentage. So it can be measured with the help of a power, not the ampere. It's not ampere measurement is not a correct. It could be it's a power measurement because sometimes the power factor is also very depends on the load condition. When the load is going to be very higher, power factor is also very high. Okay. So therefore it is recommended to measure the power, but not hourly, but at least one day once you have to measure the circulating pump power. Then we have a flue gas also available because it's a burning process. So therefore there must be a flue gas available. So that should be also monitored at the outlet of the system. Again, that should be monitored at least 3 times in a shift or 3 times at least in a day. You have to monitor, and the temperature should be within the limit of 180 to 240 degrees. More than that, then automatically the more amount of heat will be taken by the flue gas. If it is lesser, means not proper firing, not proper combustion takes place. This is the indication of your flue gas. Monitoring the flue gas itself will give you whether the boiler or TFH is going to be very properly operating or not. So by experienced people in the boiler operator or the boiler supervisors will regularly check the chimney or outcome of the chimney and what is the color of the flue gas. And they will tell, based on the color of the flue gas, they will tell how to adjust the flow rate of the water, how to adjust the feed rate of the fuel, how to adjust the ID fan air by operating the speed of the ID fan, either by throttling method or by increasing the speed with the help of a VFD control method. So those things are taken care of by the supervisor, and by experienced supervisor will know how to operate this based on the color of the flue gas. Then what are the energy efficiency options for TFH? Sometimes you can also use the agro-based system to in addition to the oil. That can be also used as an alternate fuel for that one. Okay. Now again, for other things are going to be the same for the boiler itself. You have a radiation loss, conduction loss, and that should be minimized by giving a very proper insulation, right? Then the heated oil will be going to that one, so that can be again taken to the chimney. Heated air will be going to the chimney, and there you can use a preheater. You can use a preheater, and that preheater can be used to heat up the oil, so that you can reach a very high temperature and similarly very high pressure initially. Then you can use the VFD control ID fan, FD fan, based on the temperature, based on the flow, based on the pressure. You can operate the motor either lower value or higher value. Instead of operating at a constant speed, it will take the constant power. Rather, if your temperature or the pressure is going to be lower, then you can operate the motor at lower temperature or lower speed. I told you in the previous class, when your speed will be, power will be reduced. Power is directly proportional to cube of the speed. So when the speed is going to be get reduced, then the power is also reduced. If the 10% reduction of the speed, 27% of the power is saved in the motor. So that is why we are using VFD controlled ID fan and FD fan. Keep remember what is the size of the fan, that does also matter. The size of the fan is going to be 3.7 kilowatt or 7.5 kilowatt or 10 kilowatt, something like that, then the VFD is going to be very good. Even if it is for 1 kilowatt, it is not required a VFD control. Rather, throttling is going to be better. So investing the huge amount of money in the VFD for lower HP motor is somewhat you need a proper justification. Okay. Similarly, the temperature of the flue gas to be monitored, and that should be stacked in the system. Okay. Now the heat recovery from the flue gas, something similar. You can take the heat from the flue gas by giving a spiral coil, or you can use the another heat exchanger, pass on the heat to the system, and in the other portion of the heat exchanger, will be given the circulating oil. So the oil will be get heated up. So because of that one, the oil get higher temperature that can be fed into the system. So you can see the very important point. Heat energy can be recovered till the temperature of the flue gas is 110. Even if it is a 110, you can say you can recover the flue gas temperature. Normally, you can see the 22 degree temperature reduction in the flue gas will save 1% of the fuel in the system. So waste heat recovery in the thermal system is going to be a very, very adaptive. Most of the time, it is economical also. Okay. Now, what are the best operating practices and energy conservation implementation to be done for the boiler as well as the thermopack or the TPH? Monitor the operating efficiency, especially for low load and high load application. Your boiler or your system should have at least 80% efficiency of operating. That's a very important point. Always you have to keep remember. So when you're operating at low pressure, then automatically your efficiency will drop down. So under that condition, you may club your activity. So plan accordingly. Either you can have a smaller boiler, you can use the smaller boiler to operate. So instead of operating a very huge boiler for a low pressure application, so you can have a separate boiler for a low pressure application with a small capacity. Periodically clean the fire and water tubes regularly to avoid the soot formation, scale formation. Regularly check the evaporation ratio. ER is a very simple indication, and find out whether this value is going to be in the same value in the design value or not. And if the value is going to be very lower, then you have to take remedial measure why it is going to be lower. Okay. Then steam distribution and usage should be always regularly checked. Leakage should be always checked, and insulate the flanges and valves. It is also very important. Maintain the accurate of the water ratio. If the water ratio is going to be very high, where water level is very higher, means automatically it takes more amount of time to produce the steam. When the water level is too lower, means automatically additional heat will be wasted in the insulation part of the boiler. So automatically that also will be wasted. Okay, then avoided. So preventive maintenance to be taken care for your trapping systems. Then what are the energy conservation measures you can able to take it from the boiler side and the thermopack? You have to reduce the excess air by optimizing the FD fan operation. Regularly, you have to blow down either by shift, either by manual or by automatic. You have to measure the TDS level and water quality. Then you have to do the blow down. So that will also have a good effect on the efficiency of the system. Then employ the heat recovery system. Mostly it is economical. Mostly it is viable. Lesser than 2 years is the payback period for employing the system. So therefore, it is always recommended to go for a heat recovery system. And similarly, recover the heat from the hot process like steam, streams, any other applications. You can either use it for hot water, or you can use it for some other application to heat the process. Okay, so that's all about the boiler and TPH value. I think I completed the topic on the time. Now the time is 12:25. We have 5 more minutes are available. If you have any questions, you can ask now. Use your chat box or open your mic to ask. So in the afternoon, we will discuss the furnace. There is no material for the furnace. I will show you the BE material for the furnace. Then we will go to the HVAC system. I request the participants, please open your mic or use your chat box to have any questions.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir. Sir, still now you are given the very elaborate and excellent presentation for particularly boiler. As an electrical engineer, we understood so many things. It's all new to us. Even though it is very informative for as an energy auditor. Suppose we should go for any auditing, that is a very important aspect we should know.
Yes, sir. Yes, sir.
Yeah, we should know. Thank you very much for wonderful presentation, sir. I have a small clarification from the website. Yes. That we can have so many energy conservation aspects and then procedures, everything you are explained. But okay. The thing as a auditor, we have to concentrate on the flue gas emission also. So in that side, you are not given any explanation to how you are going to measure that that the gas which is out from the boiler then how you are going to measure then whether it should be in the standard level or not? That point, I think.
Okay, sir. Okay, sir.
We have any specific measurements or methodology to adopt to monitor that particular aspect also? No.
Good, sir. Good, sir. I will tell you, flue gas measurement is very important. There are two aspects you have to measure the flue gas, sir. I will show you the flue gas analyzer in the afternoon through the video mode, so that it is very easy for you to understand whether the flue gas is going to be important. Now, there are two important points I told you, flue gas analyzer. One is to measure the flue gas. Flue gas measurement is somewhat tedious. Last week, 3 weeks back, we went to an industry to measure the flue gas analyzer where the chimney output is going to be very higher. So we can climb in the ladder by putting the belt on our body. Then we climb on the ladder, and in middle of the ladder there is the middle of the chimney there is a small hole. Always it is provided a small hole to measure the flue gas. You have to insert the probe of the flue gas analyzer into the system where the flue gas coming out, and you have to monitor for a minimum of at least 15 to 30 minutes. 10 to 15 minutes normally. That is enough to measure the flue gas. So it will show you all the parameters like what is the CO level, carbon dioxide, carbon monoxide, carbon dioxide, O2, excess air, and relative humidity. And not only this, all the other parameters like what is the percentage of excess air, and what is how to optimize, and even it will give the efficiency, approximate efficiency of the your flue gas system. That depends on the meter version. I have a flue gas analyzer which will show you nearly 8 to 10 parameters: temperature of the flue gas, CO level, CO2 level, O2 level, excess air, then the draft pressure, draft induced flow, and everything it will show. Now the idea is it will give you the amount of excess air coming out of the flue gas. Now the excess air percentage is going to be within a limit. I told you, when you are passing more amount of air in order to give oxygen to the combustion chamber, if you are passing more amount of air, then automatically the heat generated by the fuel taken away by the flue gas, which is not good. Okay. Similarly, when the flue gas is going to when the air is not sufficient, then automatically proper combustion will not take place. That will lead to more amount of CO, carbon monoxide. So both the cases can be avoided by measuring the flue gas. So this is an indication of whether your flue gas temperature, quantity, the parameters in the flue gases are proper or not, number one. So that will give you how to operate your boiler, number one. This is for our side. Number two, flue gas will have CO, CO2 and all the parameters, which will affect your local pollution. It will create local pollution. So therefore, Tamilnadu government and the central government, there is a separate ministries, separate agencies called PCB, Pollution Control Board. So they will come. Normally, if you have a boiler, the pollution control board people, TNPCB people will come to your place and they will measure the flue gas and they will give a notification if it is exceed. So there is a norms for TNPCB and you have to maintain all the values within the norms. Actually, it is available in the website. You can go to the TNPCB website and norms will be available for each and every type of flue gas boilers. The boiler with the run with the wood, boiler with run with LPG, boiler with run with rice husk, they have their own values. So that is clearly mentioned in the TNPCB, and similarly Central Pollution CPCB website is available. So they will measure the flue gas by their own machine, not your machine, and they will not accept your measurement. You are measuring with the help of my instrument. This is for your application, but they have their own measurement and they will have the values to be maintained within the limit. So there are 2 points. One is for your application, you have to measure it, optimize your boiler, and second one is you have to obey the compliances as per the pollution control board. So these 2 cases you have to measure the flue gas. third important point, if you have a higher flue gas temperature, then there is an indication for recovery the heat for your energy savings. Either you can implement the air economizer, or if you have already an air economizer, you may use the air preheater, or already if you have an air preheater, then you can use the same heat for your other process application. So you can decide, or you can design based on the temperature of the flue gas, based on the flow of the flue gas, you can go for an energy recovery option. So this three way, it will be very helpful. I think I answered your question, sir.
Yeah. Thank you, sir. Very informative and excellent. The answer you are given, sir. Thank you, sir. Thank you.
Kindly visit the website TNPCB. That will give you a clear-cut idea.
Yes, sir. Why I am asking this question is before we are get the notification from the pollution control board, whether we can monitor what should be the output of our flue gas. Then only we can face the the pollution control board.
Correct.
You know.
Correct. It is correct. Prevention is going to be very better than compared to. I mean, if the people will from the compliances board will come and test that they certified that your system is not correct, you are not within the standard.
Then it leads for closing and then notification.
Yes,
also, you know that.
Yes, sir. Very good. Very good. So something similar to that. I told you in the yesterday class, there is no harmonic penalty for 11 kilovoltage and 22 kilovoltage consumer for as of now. For 33 kilovoltage consumer, we have a harmonic penalty. Now, for the 33 kilovoltage line, if you measure the harmonic content in the input side of the transformer by your measurement, by your equipment, they will not accept. The utility people, the TANGENCO people, they have their own meter. They will come and check their own meter, and it should be within the limit. At the time of inspection, it should be within the limit. You know, there is the regulation by CEA, Central Electricity Authority, Government of India, clearly tells that at PCC, at the point of common coupling, that's called PCC. At PCC, for 33 kilovoltage line or more than 33 kilovoltage consumer, at PCC, they have to maintain voltage harmonic less than 5%, current harmonic less than 8%. This is the standard as per the CEC as of now. Okay. So when people will come and check that if it is higher, if both the value or any one of the value higher, then they will give a notification to you. You have to reduce your harmonic level, either voltage or current. Of course, voltage will be always lesser because voltage is given by the utility people. Current harmonics is our hand because our equipment will generate the current harmonics. So you need to filter out your harmonics and such that you should not dump the harmonic in the system. So that will be again inspected by the utility people, not your equipment. You can measure with your own equipment, and you can check whether you are in the limit or not, and you can take remedial measures by arranging the filters before the people will come. This is a very good point, sir. You are telling very good.
Thank you, sir. Thank you.
So good afternoon, sir.
Good afternoon, sir. Yes, sir.
Sir, you have given a nice presentation, sir. As I requested yesterday, kindly give us input on energy audit.
Yes, sir. Yes, sir. I'm on the pipeline. Thank you, sir. At the end of the presentation, I will give you how to become an energy auditor. There is a small slide is available with me. 4 or 5 slides are available. I will show you at the end of the presentation today. No problem, sir. I will tell.
Thank you. Thank you.
Thank you. Ananya madam, is there any announcement? Sneha madam?
Sneha this side. Yes, sir. So
any announcement?
I've
Can we break for lunch?
Yes, sir. I've shared the feedback forms in the chat box as well as WhatsApp group.
Okay.
And the responses are accepting for now. Yes, we can continue after the lunch break.
We can start by 1:30.
1:30. Yes, sir.
Thank you.
Thank you, sir.